Welcome to doassignment-ca. Here is the problem. A 100-kilogram crate is subjected to two forces, a 500-Newton force directed at 45 degrees above the horizontal, pulling upward and to the left, and a 400-Newton force directed at 30 degrees below the horizontal, pushing inward from the right. The crate is originally at rest on a horizontal surface. Determine the distance s it must slide in order to attain a speed of v equals 8 meters per second. The coefficient of kinetic friction between the crate and the surface is mu sub k equals 0.2. Use the work energy principle. Now let's work through the solution step by step. First, let's resolve all forces into horizontal and vertical components. The weight is 100 times 9.81, giving 981 newtons downward, taking leftward as the positive direction of motion. The 500-Newton force at 45 degrees above horizontal has a horizontal component of 500 cosine 45, which is 353.6 newtons to the left, and a vertical component of 500 sine 45, which is 353.6 newtons upward. The 400-Newton force at 30 degrees below horizontal has a horizontal component of 400 cosine 30, which is 346.4 newtons to the left, and a vertical component of 400 sine 30, which is 200 newtons downward. Since the crate moves only horizontally, the vertical forces are in equilibrium. Summing vertical forces to zero, the normal force plus 353.6 upward, minus 981 for the weight, minus 200 downward equals 0. Solving, the normal force equals 981 plus 200 minus 353.6, which gives 827.4 newtons. The kinetic friction force equals the coefficient of kinetic friction times the normal force. That is 0.2 times 827.4, which equals 165.5 newtons. Friction acts opposite to the direction of motion, so it points to the right. Only horizontal forces do work on the crate, since the normal force and weight are perpendicular to motion. The 500-Newton force contributes positive work of 353.6 times s. The 400-Newton force contributes positive work of 346.4 times s. Friction contributes negative work of negative 165.5 times s. Adding these together, the total net work is 353.6 plus 346.4 minus 165.5, all times s, which equals 534.5 times s. Setting the net work equal to the change in kinetic energy, 534.5 times s equals 1/2 times 100 times 8 squared minus 0 since the crate starts from rest. 1/2 times 100 times 64 equals 3,200 joules. Dividing both sides by 534.5 gives s equals 3,200 divided by 534.5, which is approximately 5.99 meters. The crate must slide about 5.99 meters to reach a speed of 8 meters per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.